India has made history. With its Chandrayaan 3 mission, it has become the fourth country ever to successfully land a spacecraft on the Moon, joining the ranks of the United States, China, and the former Soviet Union. This achievement isn't just a monumental step for India, it could be a game-changer for the entire field of space exploration. NASA, and other space agencies are already feeling the weight of this moment. After all, did you know that the ice on the Moon is worth 5 times its weight in gold? That's right, this discovery alone could reshape humanity's future in space. Imagine using lunar ice to support colonies or missions, effectively turning the Moon into a resource hub for future explorers. The very idea of living off the land in space, mining the Moon for its water, could redefine the way we think about space travel. But Chandrayaan 3 has uncovered something even more startling, a revelation so profound that it has even caused the most optimistic voices in theoretical physics, such as Michio Kaku, to re-evaluate everything they thought they knew about the cosmos. What did India's spacecraft discover that is causing such a stir, and why does it challenge the very fundamentals of physics and our understanding of the universe? Launched by the Indian Space Research Organisation, ISRO, Chandrayaan 3 wasn't just another mission, it was an audacious attempt to achieve what its predecessor, Chandrayaan 2, couldn't in 2019, a soft landing on the Moon's south pole. This region has remained largely unexplored, and its significance cannot be overstated. Scientists believe that the South Pole holds the key to uncovering lunar resources and understanding the Moon's potential to support long-term human habitation. The area is rich in permanently shadowed craters, and these regions are believed to contain vast reserves of frozen water, an essential resource for any future lunar base. The findings of Chandrayaan 3 made history, but they also opened a Pandora's box of questions. At first, the results were groundbreaking and exhilarating. The Vikram lander and Pragyan rover confirmed the presence of frozen water, exactly what scientists had hoped to find. This discovery alone could pave the way for sustaining future lunar missions, but what followed was even more astonishing. Alongside the ice, the rover detected minerals like magnesium and silicon, which could be used to construct infrastructure on the Moon. But just as scientists were digesting this information, something far more mysterious emerged. The Pragyan rover, equipped with cutting-edge spectrometers, began analyzing the Moon's regolith, the fine, dusty material that covers the surface of the Moon. At first, it seemed like a barren and desolate landscape, as expected. But then the rover began picking up trace amounts of a substance unlike anything we've encountered before, not just on the Moon, but anywhere in the solar system. This strange material had unusual properties that defied conventional physics. It absorbed electromagnetic radiation in ways that no known substance should be capable of, almost acting as an energy sponge. Imagine the implications: a material with the potential to harness energy in ways we've never dreamed of. The implications of this discovery were so profound that Michio Kaku, one of the most optimistic scientists in the field of theoretical physics, couldn't help but feel a sense of unease. If this material is natural, it could force us to rewrite the laws of physics as we know them. But if it isn't natural, we're left with an even more alarming question: who or what created it, and why is it there? This discovery alone could revolutionize everything we thought we knew about the universe. But the story didn't end there. As the rover continued its scans, another unexpected revelation emerged. The rover detected anomalous heat signatures coming from beneath the surface of the South Pole. These emissions fluctuated in ways that suggested they were responding to external stimuli. Initially, some scientists hypothesized that the heat might be emanating from subsurface magma, but there's a problem with that theory: the Moon has been geologically inactive for billions of years. So what could be causing these fluctuations? Could there be something else beneath the surface, something far more mysterious and unexplained. As the data continued to pour in, more and more scientists began to entertain an even stranger idea: could these heat signatures be coming from alien structures, buried beneath the surface of the moon for millennia? For decades, rumors and conspiracy theories have circulated about the moon's south pole being home to alien bases or observation posts. While these ideas have largely been dismissed as the product of overactive imaginations, the discoveries made by Chandrayaan 3 have lent new weight to these theories, forcing even the most skeptical experts to reconsider the possibility that we are not alone in the universe. But the most mind-boggling revelation came weeks later, when ISRO released preliminary data from a groundbreaking experiment conducted by the Pragyan rover using ground-penetrating radar. What the rover found beneath the surface was nothing short of astonishing. The radar detected a massive cavernous void beneath the South Pole, an enormous, hollow space buried deep within the moon's crust. What's more, the radar also picked up geometric structures within the void, patterns that couldn't have been formed by natural geological processes. The shapes were organized, deliberate, and seemingly ancient, almost as if they were part of a constructed facility. Kaku, upon seeing the preliminary diagrams of these formations, was stunned. The void beneath the surface appeared to be large enough to house an entire small city, with organized structures inside that suggested the presence of intelligent design. The discovery raised the stakes to an entirely new level. If these structures are verified, they could completely reshape our understanding of the moon and its history. Could they be the remnants of an ancient extraterrestrial civilization, built long before humans ever set foot on the moon? Or could these structures be evidence of something even more surprising, an ancient human civilization that predates recorded history? These questions are far from just academic. The implications of this discovery are staggering. If the structures were built by extraterrestrials, they could represent one of the most significant archaeological finds in human history. Studying them could provide us with insights into technologies and materials far beyond our current capabilities. This could be akin to handing a caveman a smartphone, an opportunity to leapfrog centuries of technological development. But, of course, such a discovery comes with risks. What if the technology is too advanced for us to understand? The potential for misuse could be catastrophic if we're not careful. Alternatively, if these structures were created by ancient humans, it could rewrite everything we know about the history of our species. This theory aligns with an emerging hypothesis: could humanity have achieved a level of technological sophistication long before the civilizations we know today? Some scientists have speculated that ancient human civilizations may have once reached the stars, only to be wiped out by cataclysmic events like asteroid impacts, supervolcanic eruptions, or global climate shifts. If these ancient humans reached the moon, it could mean that our potential for exploration and innovation is far greater than we've ever imagined. But the most chilling possibility of all is that these structures are still active. The fluctuating heat signatures detected earlier suggest that there may be a functioning system beneath the surface, a system that is, for some reason, responding to external stimuli. What if these structures are still operational, possibly part of a larger system designed to communicate, observe, or even protect itself from intruders? Could disturbing these ancient structures provoke an unintended response? What if we are unknowingly interacting with something far more powerful and dangerous than we can comprehend? For all the excitement and wonder these discoveries have generated, they've also raised some very serious ethical questions. Should we proceed with further investigations into these structures, knowing that we may be disturbing something far older and more dangerous than we understand? As Kaku has warned, we need to approach these findings with extreme caution and humility. The universe is vast, and its mysteries are far beyond the scope of our current understanding. Meanwhile, back on Earth, scientists are scrambling to analyze the data and develop new theories. The discoveries made by Chandrayaan 3 have sparked a renewed interest in lunar exploration, and new missions to the Moon's south pole are already being planned. These missions will face tremendous challenges, both technical and ethical, as they seek to uncover more of the Moon's secrets. As we look to the future, it's clear that the path forward will not be easy. The potential for discovery is limitless, but so too is the potential for danger. Whether these discoveries represent hope, fear, or something in between, one thing is certain: humanity is standing on the brink of a new era in space exploration. Chandrayaan 3 has not just uncovered a few more mysteries of the Moon, it has opened Pandora's box, revealing possibilities that we can barely begin to comprehend. As we continue to explore the Moon and beyond, we must do so with open minds, open hearts, and a deep sense of wonder. For in the vastness of space, we are only beginning to uncover the truths that lie beyond our understanding. The journey